Today we are going to see the assembly language programming of 8051. So in the last class we have seen how 8051 microcontroller is different from 8086. Okay, so then the differences between processor and then the controller and then the hardware features and architecture point of view of 8051 is what we have seen in the last class. Today what we do is the first 45 minutes I'll be try to give you the addressing modes and instruction set of 8051. So we'll discuss that. So you will be comfortable in writing programming whenever you come across or whenever you use 8051 microcontroller is. Okay. So with that we'll start, and in the next the next 45 minutes what I'll be doing is I'll give you the brief introduction about ports of 8051. So in the next class what we do, interfacing of analog to digital converter, LCD and all, how can you do using microcontroller is what we can try to learn. So now let us start today's class with if you want to use 8051, then how to come across and how to use is what we will try to see in this particular class. So now let us start with, so in the last class we have seen coming to the registers of 8051. These are the registers available, accumulator, B, R0 to R7 registers, and data pointer, and then the program counter or the instruction pointer, and then the stack pointer. So these are the registers available with 8051. And coming to the memory mapping, so you can connect externally a ROM of 8K. Okay, this is Atmel 89C52. But 8051 point of view, we try to see, you can connect to 4K external ROM. And coming to the RAM, so you have 256 bytes of RAM. Okay, you have 256 bytes of RAM. In the last class, we have seen very clearly this RAM and then functions of RAM is what we have seen. How the RAM can be used. Okay, so now before going to write the program, discussing about the instruction set, now let us try to see the RAM in detail so that programming become very easy. So now you have the RAM of 256 byte, and in the 256 byte, this RAM is of 16 bytes of RAM. 20 to 2 have Bit-Addressable, and we can use only single bit instructions. So these instructions use only direct addressing mode. So now if you try to see here, the 202 here, this one. So the 20 to 2F, 20 to 2F, yes, this memory, it is called Bit-Addressable, means you can set or reset individual bit. So we can use this instruction set bit clear, set bit 1, clear the bit 0, particular location of that. If it is starting with 20, the 20 bit you can do set or reset. And you can use complement bit. If it is 1, then you can jump somewhere else, jump 1 bit. Okay, so these things you can see. Alright, so jump below carry. These are the instructions we can use. Now in detail, if you try to see, this is 20 to 2F memory, each of 8 bits, so 00 to 7F. Okay, so 16 bytes. So 16 bytes each bit of 0 to 7F. So you can make this 1 or 0. So now if you try to see, find out by which of the following bits belongs. Now set B 42H. So now if you try to take this 42H, so this is used in direct addressing mode. So we have to know the addressing modes in detail. I'll try to explain now. So this particular bit, it will become 1 or 0 when controller executes this particular instruction. So set B 42H, clear 67H. So this will become 0. And clear 0FH. So clear 0FH means this one. It will be made 0. So bit-addressable memory, if you try to see, here you have 0, 1. So this is D0, D1, D2, D3, D4, D5, D6, D7. So 8 bits of this 20 means D0 of 20, 21, 22, 23, 24, 25, 26. So set B 28H. So that means this 28H it will become 1. So like this, we have, so here to give a summary, you have these registers for programming. So user can use these registers. Okay, these registers user can use. Data pointer user can use. Okay, right? So then 4K is the external ROM is what you can connect. Okay. All right. And now, and the RAM, which is of, so this is the RAM memory, 00 to 7F. Right. So this is the memory you can use. Right. So in this 20 to 2F is bit addressable. And this is how you can write instructions. So before going to write instructions, we have to know the addressing mode. So what is addressing mode is the way of locating data in the instruction. So now if you try to see immediate addressing mode, so the addressing modes which the 8051 supports is immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, relative addressing mode, absolute addressing mode, long addressing mode, and indexed addressing mode. So now we'll see in detail what they are. So coming to the immediate addressing mode, the source operand is a constant. Now if you try to see move A, comma, at 25H, means in the instruction the data is immediately present. So the source is a constant and the immediate data must be preceded by the pound sign. Pound sign. So move A pound 25H means the accumulator is loaded with 25H constant. Okay. So you can load the information into any register including 16-bit data pointer. So you can load 62 data into R4, or you can load some 40 into B register, and data pointer is a 16-bit register, so 45 to 1 can be moved into data pointer. And data pointer also, it can be also accessed as two 8-bit registers. So the high byte DPH and low byte DPL. So you can directly move 16-bit data into the data pointer, or two instructions you can write. Move DPL 50 and move DPH 25H. So move data pointer 68975. This is illegal because this value is greater than 65,535. So you cannot move this. So in registers of A, B, R0 to R7 and data pointer, you can move by using this addressing mode the data, which is immediate addressing mode, means the source operand is a constant immediately available in the instruction. And this immediate addressing mode, the moment you are using key kind of assemblers or the softwares, then you can use this equivalent directive to access immediate data. So now if you are writing count equal 30, so then you can use this instruction move R4 comma at the rate 30, or move pound count. So that means the count which is equal to 30 will be moved into R4. Right. So we can also use the addressing mode to send data to ports. Example, move P1 comma 55. So as we discussed in the last class, 8051 has 4 ports, port 0, port 1, port 2, port 3. So you can move data into the ports directly. So move P1 comma 55 means 0101 0101. So this is D0 to D7. Right, D0 to D7. Okay, so D0 to D7. So now this will be moved into port 1. Okay, so you can use immediate addressing mode to send data to ports also. And coming to the next addressing mode, that is register addressing mode. So moving of the data from one register to another register. So copy the contents of R0 into A into R2. So copy the content of R0 into A and move A into R2, or add accumulator with the content of R5. Okay, and move. So these are the instructions you can use. So here the source is register, destination is also register. So that's why it is called register addressing mode. And the source and destination register must be in same size. This is 8-bit register, this is 8-bit register. And the source and destination registers must watch inside. See, now we cannot move A into BPTR. Means A is of 8-bit, BPTR is of 16-bit. So you cannot move this 8-bit into 16-bit. Okay? And now this is what? The movement of data between R and register. So move R4 and R7 is invalid. You cannot do this particular task. If you have to move through accumulator or some other register. Okay. So this is moving this number into DPTR, and DPL can be moved. Means lower byte can be moved to R7 and higher byte can be moved to R6. So this is what the syntax of register addressing mode. So remember, this task you cannot perform because the source and destination should match. This is the first one, and you cannot move the data within the registers. The next one is direct addressing mode. So what is direct addressing mode? We discussed this in 8086. Instead of specifying the data in the instruction, or the data is transferred from register to register as in register addressing mode, here the source or destination can be memory location. So here the memory location is of 256 bytes of RAM. In that we are going to use 0027F and move R0, 40 means that 40 location, the content of the 40 will be moved into R0. The byte which is starts with 40 will be moved into R0 register, or move A, 56. So from 56 onwards, the bytes of accumulator is going to be saved in the memory or moved into the memory. And move contents of RAM location 7F to R4. So this is how you can do. So this is what the direct addressing mode. So in direct addressing mode, the source or the destination are memory locations. And here move A, 4, which is this 4 is of R4. So this is same as copy the content of R4 into accumulator. Right. Move A. This is anyhow, this is register addressing mode, but this is also, you can specify this 4 or R4, which is offset. All right. And move A, R0. So you can write like this also. But here there is no pound sign in the operand. Okay. And coming to the register addressing mode. So register indirect. So we have seen direct addressing mode. Now let us try to see the register indirect addressing mode. So in direct addressing mode, we will be specifying the address of the RAM location in the instruction. So the advantage is that in register and indirect addressing mode, it makes the accessing data dynamic rather than static as in direct addressing mode. So looping is not possible in direct addressing mode, but looping is possible in register indirect addressing mode. Take this example. Write a program to clear 16 RAM locations starting from RAM address 60. Write a program to clear 16 RAM locations starting at the address 60. The program is clear accumulator means all the content of accumulator will become 0, 0, 0, 0, 0. So now the task is what? 16 bytes you have to move. So 60. Okay, you have 60 and then 61. So this is what your memory location addresses. Right. So now what you can do, each location is of 8 bits, so now you have to fill this with zeros. So now move R1 comma 60, this one. So R1 is, so now we are moving 16 to R1 and the counter is 16 RAM locations, so that I am using as R7. So now move A is having all zeros, so at the rate R1 is holding 60, then increment R1 will become 61, and if R1 is not becoming, jump no 0. Okay, DJ and J, I will try to discuss this. DJ and J is about one addressing mode. So jump on no 0. If R1 here is of 60, so if it is no 0, then if jump no 0 R7, then again come here. So move the content of R1 at, so that means, you know, at the rate, this is what indirect addressing mode. Indirect, it means using the registers as pointers, using this at the rate. So increment R1 and decrement R7, and if it is not 0, then back to again. So this instruction decrement, and if it is not 0, the R7 if it is not 0, because 16 bytes, right, then it will go back. So the looping is possible in indirect addressing mode. So it is widely used. Now let us take this example. Write a program to copy block of 10 bytes data from RAM locations starting at 35H to RAM location starting at 60H. So you have the RAM. So now what is the task? So now 35, 36, 37, 38, 39, like that you have 10 bytes. So this you move to the top of the memory, the locations which are starting from 60 onwards. Okay? So now the instructions are move R0 comma 35. So the 35 will be moved into R0 and R1 is the 60 and 10 bytes you have to move. So this is what the counter, and if it is 10 bytes, then you can write here A. Okay, so you can give the data whether it is in decimal or hexadecimal, so on. So move what is there at 35 at R3. Okay, so at the content, what is there, you move into accumulator, and from accumulator you move into the memory location. Increment R0 and then increment R1 and decrement R3 is where you are putting a counter. So decrement, and if it is not 0 then go back. A small set of piece, a small piece of program you can write using indirect addressing mode where the registers are used as pointers. Okay, the registers are used as pointers. So here you cannot use all the registers as pointers. So R0 and R1 are the only registers that can be used as for pointers in register indirect addressing mode. Since R0 and R1 are 8 bits wide, their use is limited only for the internal RAM. And if you want to point out the external RAM or ROM which is connected to 8051, then you have to use data pointer register. Okay, so here R0 and R1 are only used as pointers. Okay, so keep in mind this one. So this is the syntax is move accumulator at the content of Ri where I is 0 or 1 only. And now if you try to see relative, absolute and long addressing modes, S jump is a short jump. A call, calling subroutine somewhere in the memory. A jump, long jump, and long call. So means here you have RAM of 256 bytes only. And you have a ROM which is a 4K internal, and external you can connect up to 64 KB. 64 KB. So here you have the data pointer which is of 16 bits. So 2 power 16. So 64 KB is what externally you can connect ROM to your microcontroller. So then within 64K, jump could be long jump or the short jump. So what do you mean by this long jump and short jump? If you have 256 bytes of RAM memory location, so you can go forward jump, you can go plus 127. Backward jump, you can go minus 127, 128. Then you can, that particular jump is called S jump, short jump. And calling subroutine somewhere written in the external ROM or in the internal ROM, then you can use these kind of instructions. So this is what the long addressing mode, relative or long addressing mode. Then coming to see index addressing mode. So this mode is widely used in accessing data elements of lookup tables. And the lookup table entry is located in the program space ROM at 8051. So move C is the command, program code. So move C accumulator at the rate A plus data pointer. So the content of accumulator added to the data pointer can be moved. So from that particular memory location, you can move into the accumulators. So this is what the index addressing mode. So 8051, 8086 has source index and all can be used as the index registers. Similarly, here you can use this addressing 8051 also supports this. The content of address A, accumulator is added to the data pointer from ROM location is moved into A. Meaning is that. So these are the few instructions. So move instruction you have destination comma source. Source can be immediate data. Okay. So now move into the B register with the memory location of F9 into B. Okay, so this is move instruction. So move from ports also you can, something which is there in accumulator can be moved into ports. So now here just make a note, move A comma 72. So here this 72 is the byte which is moved into accumulator. So this is not equal to move A comma 72 because from the memory location 72, that byte will be moved into A from the memory. But here 72 itself is moved into A. Okay. And move A comma R3 is move A comma A3. So then you can write directly the address here R which is equivalent to R3 is what you can say. So that's why writing program only you can do if you know exactly the memory mapping is, especially assembly language program. So this is one instruction, add. So add A with source. So anything here it is not like 8086. Anything the addition subtraction you wanted to go for, do it with only the accumulator. So the content will be accumulated back into A register. So add A comma 6. So the content of, so A is what? A plus the 6 number. Add A comma R6 means the content of A and content of R6 both are getting added and result will be stored back or accumulated back in accumulators. So this is also direct addressing mode. This is register addressing mode. So here this is also same, right? So now coming to subtraction. So A is A minus source. It's A minus the source. Subtract B, the borrow. So A is A minus 6. From the content of accumulator, from that the 6 is getting subtracted. And coming to the multiply and divide instructions. So mul AB, so the content of A and content of B both are going to be multiplied and stored in accumulator mul AB. Okay, so if you have A and B, it is 0. Now you see 25H and 65H are the contents of accumulator and B register. And if you write an instruction mul AB, so here if you multiply, the result is 0E99. So 99 will be stored in A, 0E will be stored in B. So this is what the syntax. Because when you multiply to 8 bits, the result will be 16 bit. Alright. And div B. So A by B if you do, which is B is A mod B. So move A comma 25, move B comma 10, div AB. So then A will be having 2 and then the accumulator will be having, B will be having 5. So that means your reminder quotient, right, reminder quotient divisor. So divisor, dividend. So accumulator and B register will be holding. And you can have these instructions also, set bit or clear bit. Single bit, you can make it on or clear, set or reset. Okay, so these are few instructions. And DC is decrementing a byte and incrementing a byte. So increment R7, decrement accumulator. The content of the accumulator will be decremented by 1. The content of R7 will be decremented. So now the moment you write decrement 40H. So 40 is a memory. So then when you say this is, then it will goes to 39. Okay. And here you have command rotate right. Rotate right is simple logical rotation. So now this is D0, D1, D2, D3, D4, D5, D6 and D7. Rotate right means each bit will be rotated by 1 bit, but D07 will become D7. The content of D0 will become D7. So rotate right through carry. So rotate right through carry. So here it will rotate right. So the D0 will goes to carry and the carry content, carry flag will be going into D7. And similarly you have rotate left and rotate left through carry. And logical AND, OR and XOR operation, bitwise logical operations. So now if you have move R5 comma 89H and L, so R5 is having 89, 89 and logical AND, so this is what you are moving into R5 and here you are using so logical AND operation when you perform, this will be 0, this will be 1, 0, 0, 0, 0. So you can mask off the higher byte by using this 0, 8. So the result is this. So logical AND, bitwise logical operation. And CPL is complement A. So now, if accumulator is having 5, 5, 5 and 5, five, 5. So then, if you complement it, so this is will be your content. So it will become AA. Okay. And coming to the stack, so we have seen in the stack. So if you have the stack, so move pushing the flag registers, flag register contents into the memory location. So your stack pointer will be pointing at 07, 08, right? So then stack pointer is 09 kind of. So push 1, push 6 means here the content of the flag register can be pushed locations. And loop and jump instructions you have jump on 0, jump on no 0, decrement if no zero, jump to particular location. Okay. Compare, and if they are not found equal and then jump. So compare and jump, and if they are not equal, so here this can be resistor and then the data. Jump on carry, jump on no carry, jump below, jump no below, right? Jump on below carry. If it is carry, then below. So write a program to clear accumulator, then add 3 to the accumulator 10 times. So this is what the program given. Write a program to clear accumulator, then add 3 to the accumulator. So move a comma 0 and move R10. So 10, right? And add a comma 3, decrement R2. If it is not 0, then again add 3. Decrement R2. If it is not 0, then add 3. Okay, so then move the content of A into R5 something. So repeat until it 10 times it happens. So long jump is unconditional jump, and it allows a jump to any memory location 002 FFFH. 64 kilobytes is long jump. Absolute jump is 2-byte instruction, and it allows to jump to any memory location within 2K block of program memory. Short jump, as I said, forward jump you can go for plus 127, backward jump you can go for minus 127. And call instruction. So this is 3-byte instruction and can be used to call subroutines located anywhere within 64 kilobytes. This is long call. Absolute call, a call is 2 bytes. Within 2 bytes you can call the subroutine. Example, write a program to copy a block of 10 bytes from RAM locations starting at 39H to RAM location starting at 59H. So 37 is starting, 59 is the destination, and move, and you can use R0 and R1 only the pointers. So this is what your counter. So move accumulator at the rate of 0. So this memory R0 is at 37, so the content of that memory location is pointer moved into accumulator, and move that to the pointer R1, then increment R0, increment R1, so decrement R2, which is a counter. If it is not, then go back. Simple program you can write. So to copy the data from one memory location to another memory location. Okay, so now these are the addressing modes and some of the instruction set, and you can go in detail of performing this particular. So now this is about the addressing mode and instruction set of 8051. So now what we do, we will try to see the ports of 8051. So programming point, a little bit we have seen the 8051 and all. So the addressing modes and instruction set what we have seen. Whenever it is needed, you just refer the syntax and then you can go ahead. Is it all right? So now let us discuss the important topic, which is ports of 8051. So now let us try to see. the ports of 8051, which is very, very important. So if you are going for programming of 8051, then it is needed to know about the ports. So now coming to the ports of 8051, you have 4 ports: port 0, port 1, port 2 and port 3. So 4 ports, each port of 8 bits. The pins of these ports you can see. It is important that you have to know about the ports, because the moment you see, now this is what your microcontroller. To the microcontroller you want to interface a temperature sensor. A temperature sensor can be interfaced to the microcontroller through the ports. So the ports are on board. So any temperature sensor you want to interface, so then that you try to do with ports. So when we are discussing the microcontroller and 8255, so we have seen like the requirements of the ports. So the requirements of the ports. So now if you try to see, a port can be of input port and the port can be of output port. So input port means which is used to read the data into the microcontroller, and output port means writing out into the devices. So microcontroller will work with the frequency of 5 megahertz. That means within 0.2 microsecond it can send data. 5 megahertz, 11 megahertz, right? The clock of microcontroller 8051, okay, 16 megahertz, so on. So within fraction of second the microcontroller gives the data. So now let us try to take here in 8051 a LED has to be connected. So LEDs, now let us take an example. 8 LEDs has to be connected, and they have to make alternately on and off, on and off, on and off. So then what you do? This is what your port 0. So port 0 can be connected through a resistor to an LED. So this is port 0.0, port 0.1, port 0.2. So you can connect LEDs here. Your task is to make these LEDs on or off. Okay, on and off. So on. Right. So now microcontroller can send data within microsecond, but you cannot see the flash of the LED. It should be in milliseconds. So then what you can do, that to retain the data, the requirement of an output port. So the requirement of output port, it should have a latch. That's what we have seen. So output port should have a latch, and input port should have a buffer. This is already we discussed. If you have a keyboard, and now if the key is pressed or not, now let us take if it is connected to VCC. When the key is pressed, this current can damage your pins. So then input pins should be buffered, means it should have high input impedance. So to differentiate, to isolate your input devices with the microcontroller, so then the output port should have a buffer. So the moment we are talking about ports, so input port should have latch, and output port should have latch, and input port should have buffer. And that is what the hardware requirement of a port. So now let us try to see this. Okay, now let us try to see this in detail. Okay, so now if you try to see here, the port pins of the port pins of 8051, if you try to see, should have a tri-state buffer, should have a latch. Now if you try to see, so this is what your D latch, and you know the operation of D clearly. So if you want to write 1 here, and this has to be reached to the output, you have to give a clock. So if it is positive, negative edge triggered means during this, if D is 1, then only the Q is 1. And during this period, the D is 0, then Q will become 0. This is a simple D flip flop. So this is what the port pins of port 1. So it has a latch. It has a latch, and it has bidirectional buffers. These are the buffers. Okay, so this is to read input. So this is what read latch. Reading of this particular latch can be done by using this. Reading of port pin can be done by using this. So this is P1.x, means P1 port 1. So P1.0 means the 0th pin. P1.1 means the first pin, and P1.7 is the last pin of the port 1. So it has latch, and it has buffer. So it has buffer. So reading operation can be done by using buffer. Okay. So now let us try to see how to read what is there on the port pin and how to write into the port pin. Now let us try to see in detail. So if you want to write, so the moment you want to write, you can write either 1 or 0 from the microcontroller. So then if you want to write 1, then writing 1 here, so then you will simply give 1 here on a data bus. So the moment it is 1, Q will become 1 and Q bar will become 0. So when Q bar is becoming 0, so this transistor is off. And when this transistor is off, then the VCC is connected to the port pin. So 1 will be available here. Right, so this is how you can write 1. Okay, so this is 1, this is 0, so it is off, and then now it is connected to VCC. So output is 1. So now if you similarly if you want to write 0 onto the port pin, so you will give 0 on the data bus of 8051. So when it is D0, Q is 0, then Q bar is 1. Q bar is 1, then this transistor is on. So this is, you can take it as MOSFET. When this transistor is on, this point is connected to ground. When it is connected to ground, you can read 0 here, which is an output 0. Okay? So now, this is something different. Now, reading of input pin. Reading of input pin means whatever it is there on the port pin, now you want to read it. So reading can be done through buffer. So this has to be done through buffer means this transistor should be made up. Then what you do is the moment you are going for read operation, you have to write 1 into the latch. So you will write 1 into the latch. The moment it is 1, then Q bar is 0. When Q bar is 0, this is off. So then here if the port pin is 1, so then this is off. And so this point is neither connected to VCC nor ground. This is at high impedance state. So port 1, right? So port 1 is readed. Then whatever is there, it will go into the buffer. And then now you can read this particular pin. Whatever, if it is 1, the 1 you can read it. And similarly, so this is what? So this is 0 and 1, and then it's 1, then that 1 you can read. And reading 0 is similar. You have to write 1 here. Port 1 FF is what you have to write. So it will become 1. So then Q is become 1. And Q is 1, Q bar will become 0. So when Q bar will become 0, when transistor is off, so then this is 0, so that 0 can be now read into the microcontroller. So this is how you can use the port pins of first port. So as we discussed here, port pin, how it can be used as input port or output port is what we have seen. But now as we seen in the last class, port 0 the pins of 8051, if you try to see, so the pins of 8051 are this. So port 1 is what we have seen the operation now, right? See, port 1, how it can be used as input port and output port is what we have seen. But coming to the port 0 differently, it can act like port 0. So 7, it can be input port or output port. So, and then now if at all, if you want to connect any memory external, so external ROM or external RAM, if you want to connect it to the microcontroller, so then here the same pin can be used for multiple purposes. So the lower address is by 80, 81, 82, 83, 84, 85, 86, 87. So lower address will be carried by port 1 and higher byte of the address will be carried by port 2. So total you have 16 address lines. So the 16 address lines, so that you have 2 bar 16, so 64 kilobytes of external ROM or RAM you can connect it to the microcontroller. Then, so these pins 39 to 32 are the special pins. You can use port 0 as port input port or output port. This is the first primary task. Second task, the moment you connect any external ROM or RAM, then the lower byte address will be carried by 39 to 32. That is the second use of port 0. And then the third is the data can be carried by this. So AD0 to AD1. So address bus and data bus are multiplexed in port 0. So then now let us try to see in detail about port 0 so that we can understand the use of this. So being clear, port 0 is having 3 functions. So port 0 is having 3 functions. So now let us try to see the port 0 in detail. So the port 0 internally, as it performs 3 tasks. So one task you can use port 0 as input port, output port. So input port or output port, or you can use this port 0 as carrying the address, lower address of ROM or RAM, and the third task is it can carry data, 8-bit data. So 3 tasks port 0 will do. So now you have D latch, and here you have a control logic. So the moment it is used as a port, so then this part will be coming up. And when the moment it is worked as an address, so this part is coming. So here you need two class 1 mux. So two inputs it can take either from address or data from the controller or the ports. So that can be selected, any one of these can be selected by using control signal. So if you want to use port 0 as an input port or output port, then you have to give 0. So the moment you give 0, this line is getting selected. And if you want to use it as an address or a data bus to the external RAM or ROM, so then you have to give 1. Remember? So here you have an additional hardware in port 0. That is, here you have address or a data and then 2 cross 1 mux. So now let us try to see this port 0 as an input port or output port. So if you want to use this port 0 as input port, then you have to write 1 here. So the moment you write 1 here, Q is 1, and if you want to use this port 0 as input port or output port, control signal should be 0. The moment the control signal is 0, so this is not selected, this is what selected is. So when it is 1, then this is 0. So when it is 0, this line is connected here, so this is 0. So when it is 0, whatever it is here, so this is 0, output is 0. So when output is 0, this transistor is off, and then this transistor is off. When these two transistors are off, this will be at high impedance state. So that means this point is neither connected to VCC, these are not connected to ground. So this will be at high input impedance state, high input impedance state. All right. So then whatever is there here through buffer, you can read into the database. Okay. So if you want to read 0, if it is 0, then you can read 0 here. If it is 1, then you can read 1 here on the bus of this particular thing. Okay. And now if you want to use this as an output port, input port is what we have seen. The moment the 8051 port pins are going to be used as an output input port, then you have to write 1 first. That is the must. Because you are reading through buffer, that can be done through writing 1 into the port pins. So generally the instruction which you write, if you are using this as input port, so move port 1 as 0FF. This FF is 1 is what you will write, so when the moment you are using your ports as input ports, so this is what the instruction you have to write definitely. So if you want to use port 0 as an output port, writing here 0, this will be 0, this will be 1. So you will be giving clock. So this will be 1. When it is 1, so then this is 1. When it is 1, so this is 0. So this is 0, 0. So this transistor is off. Then this transistor is on. When this transistor is on, it is connected to ground. So then here, this 0, that means this is ground. So and the output pin you can write it as 0. So if you want to write a 1, so then this is 1, this is 1. Listen carefully. So this is 1 and this is 1. Then Q bar is 0. When Q bar is 0, this is 0, this is 0. So this point is neither connected to VCC nor connected to ground. So then here what will be available on port 0? So to come across over this disadvantage, so here what we do is we will connect externally one resistor here. So the moment we connect one external here, resistor here, so this point is pulled up to VCC, so one will be available on the port bin. So when as port 0 is doing multiple tasks, so when it is used as an output port, so this point is at high impedance state. So then this point, to pull up this point at VCC, we will be connecting pull-up resistors. So the use of this pull-up resistor is to just pull this point at a particular logical state VCC. And other than that, no task of this pull-up resistor. So this is at a high impedance state. So this is what we are doing. So port 0, when you are using as input port or output ports, then what you do is you will connect resistors for each pin, and this is how you try to do the interfacing. Now here you can connect your sensor, you can connect your LCD, you can connect your anything, keyboard or anything. So the pull-up resistors is what you use the moment you use port 0 into as an input port or output port. And then let us try to see the port 0. The moment port 0, when you are connecting, you are using the port 0 as input port or output port. You can use port 0 to carry the address also. So now let us try to see that particular example. So when you connect external memory, then lower byte of the address of that particular external memory will be carried by using port 0, and higher byte will be carried by port 2. Okay, so then the hardware of port 0 is like this. So then what you do is, to use it as an external memory, you will connect here 1. So when this is 1, and if you want to write, that means if the address, if it is carried by port 0, the data bus of this, if it is 1, so when it is 1, then this is 0, this is 1, this is 1, then this is 1, so then your transistor is on. When the transistor is on, right, so this bit will be carried here, so this will be, the moment it is 1, so this bit will be getting selected. So this is 0. When this is 0, this transistor is off. When this transistor is off, so then this 1, okay, this 1 here. So now, if address bit, it is 1. So then when it is 1, then this is on. When this is on, this VCC. Yeah, so this VCC will be 1. So then that 1 will be carried by port 1. Okay, so this is carrying 1. Similarly, carrying 0 can be seen. So if it is 0, it will be 1, and when it is 0, and when it is 1, the output is 0, so then this is off. So when this is off, this is 1, so then when it is 1, right, this transistor is on. When this transistor is on, this is connected to ground, so you can read 0. So when you connect an external memory to port 0, then you can use this port 0 can be used as carrying the lower byte of address. So port 1 is already we have seen in detail. Okay, and coming to the port 3, so port 3 has multiple functions. Okay, so here port 0 we are using pull-up resistors, and coming to the port 3, the same thing, but you have here the NAND gate. So alternate output. So the port pin, each pin P30 can be used to receive data. P31, you can use port 3 as input port and output port. Apart from that, you have different functions. So receive serial data. So then transmit serial data out. And interrupt 0 and interrupt 1. External interrupts can be connected to these pins INT0, P3.2 and P3.3. And external timer input. So the timer inputs, you can use 8051 as on-chip timers. You can count events by using this T0 and T1. And the related SFRs are SBUF, timer control, and timer mode, T0 and T1. And write bar, external memory writing pulse, and external memory read pulse. So port 3 has multiple functions. So this is about port 3. Okay. So now, and port 3, if you try to see here, so these are the alternates. This is what the port pin 10 P30, which also can be used to receive data, transmitting data, and connecting external interrupts, and then timers and external memory reading and writing. Okay, so this is about port 0, port 1, port 2, and port 3. So in this class, what we have seen is, we have seen the addressing modes and instruction set of 8051. And I didn't cover the fully in detail, but few instructions I have covered, so the rest you can go ahead. And very important topic which we have seen today is ports of 8051. So ports of 8051, this is very, very important. The moment you want to control, so the moment you want to connect your controller with external devices, then this programming of these ports are very, very important. Okay, so port 0, port 1, port 2 and port 3. So these ports is very important to understand before you want to connect or control anything by using microcontrollers. So is that all right? So port 0, port 1, port 2 and port 3. The function. So next class what I do, I'll try to interface LCD and analog to digital converter with 8051. So then we will be using these particular port pins. Is it all right? So now so is this understood? The ports and all. So very clearly I have explained, okay, very clearly I explained the working of port 0. Okay, so the summary is, if you want to use port as input port, then write FF into the ports. And if you are using port 0 as input port or output port, you need to connect pull-up resistors, as I have shown in my slide. And port 1 straight away you can use it as input port and output port. So I have very clearly discussed port 0, port 1 and port 2 is similar. You can use pull-up resistor there also if you are using input port and output port. And port 3 as usual, no need of connecting any external pull-up resistors. So is that all right? So this today's class I'll wind up. So you just go home, try to see the different addressing modes of 8051 and start writing simpler programs by installing Keel software. Is it all right? So the Keel software is what you install in your computer and then you start writing your program by using the addressing modes which we discussed. And the port pins and then the hardware of port is what we have seen now. So tomorrow I'll interface 8051 with LCD and analog to digital converter and digital to analog converter, and I'll try to use the today's content as input port or output, right? So that we'll stop this class here. If you have any questions, you can type so that I'll be addressing. Usage of port pins are very clear. How to use port 0, how to, and this we did in microprocessor using 8255. We have to connect 8086 and then 8255 and external devices. But whereas these port pins, they are available on the microcontroller pins. Is this clear? So if you have any questions, then you can post me or you can message me. I'll be answering you. In detail, it's very important. There may be asked, usage of port 0. The hardware, it can be 3 functions. Port 0 can be used as input port. Port 0 can be used as output port. Port 0 can be used as address bus. Okay, address bus. And can you are connecting external devices to the microcontroller. So this should be given very clear. So I have discussed this with the hardware and we will be meeting in the next class. Is it all right? So this is very important. Just go home and then you just refer. If you have any questions, in the beginning I will take up any questions if you have, then we can go ahead. Okay? Thank you very much.